Hey everybody, so this is going to be the demo for the Grasshopper Ladybug assignment. So this demo assumes that you have already gone through the process of installing Ladybug as well as the Radiance install on your computer, so you already have this working. The next step you will need is the final link here, which is the solar data. It'll take you to this website. So ahead of time, we're going to need to get information for Cincinnati. This is climatic information. So if we just type in Cincinnati, Ohio, we'll get a couple sources here. Basically, a lot of this sort of climatic data that involves wind and solar often comes from airports because they're taking these measurements all the time anyways. So if we just click on, we can just go to CVG and go to the one that actually, there's a couple here, but I'm just going to go on that is CVG. One of these is Covington. And just go to download one building. Now for me, that tells me Chrome says shouldn't download this. I'm just going to tell it to keep it anyways. I have tried these. They have been safe so far. So this will bring up a series of files that look something like this. I'm just going to drag them to a known location on my computer. If you are concerned, of course, you could run a virus check or something, but from my experience, these have all been fine so far. So no reason for Chrome to be concerned. Anyways, so I have too many things open right now. I have also opened a fresh public pool site, one of the clean files that I distributed, and I've actually imported a sample model of a project. So for this example, you could import any of your current design iterations for Studio. And if you are one of the students who are no longer taking Studio, and are just taking skills, just create something that looks similar to this. Just simple forms that fit on the site. Otherwise, we're going to start off with the same 2D site. I believe it has the elevated topography on top. And I'm actually going to turn that off as well as sidewalks and really just get down to sort of a minimal amount of information. We don't need to show anything really other than the site, and the roads will be plenty for this analysis. Everything else is kind of superfluous. However, the next thing we are going to need is, I have open here, I'm going to undo some things because I already did this once. Basically, one of the files that one of the sections had made of the buildings. And instead of doing the process we did last time where we actually either did a work share or directly inserted this into our files, in this case, what I'm going to suggest doing is actually just bringing this in directly. However, before we do that, we don't need any of the elevation information. We only need the building forms. So the first thing I'm going to do is the command SEL block instance, which just selects all the blocks in the model, which are these here. And I'm just going to type explode because I don't want them to be blocks anymore. I just want geometry. And now I'll type in SEL CRV, which is SEL curve. It selects all the curves, and I can delete those. Now, these, for whatever reason, are still in a block. I think there was a block inside of a block, so I'm just going to delete those. And now I will just do SEL polysurface, which selects everything. This building back here is actually a mesh or something, so I'm not going to select that one. But either way, I'm going to take all these, hit Control-C, and go to my other model and hit Control-V. Because all I want to do is bring in the building forms, because I'm really only interested in them to cast shadows. So I don't need any of that elevation information. I just need the buildings that have, the proper roof lines and heights and general mass and volume that we can use for solar calculations. So this is what you should start off with. You should have some, again, very simplified version of your current design, whatever it is, doesn't matter too much. Roofs and general volumes are nice things to have, and you'll see why later on as we go through the process of developing this. We can get a lot of detail out of the solar analysis, so we have a roof projection like what we have here. We can figure out what the implications are for how much light is going to hit different parts of the building. So I'm going to start with Grasshopper, and I'm going to snap this to one side. I'm going to snap my Rhino to the other. So again, this assumes that you've already completed the install of Ladybug and you have it working properly. The first thing we're going to need to do is this guy here, which is LB, or Ladybug import EPW. So we need to import all that data. Now it gives you this gigantic panel here. If it is glowing red, not orange, very likely your install is not complete and you need to go back and look at the install instructions to make sure that you followed all the steps. There is a step at the end that's easy to miss, and it will not run properly without that. So basically, we need to link in that file that we just downloaded. So I'm just going to do file path, which brings up this guy here. And I just double clicked to bring up the search menu, file path, looks like that. And right click on it to go select one existing file. Of the files I just downloaded, I'm going to go to the one that says EPW. There's several in here. EPW is the only one we're actually going to be concerned with. And then I'll just link that in. And essentially, this thing should now glow gray, which means it is working. And we're getting all this different information. There's a lot of information here. We're not going to be concerned with everything right now. We could certainly do a lot with this, and there's a lot more advanced things that we can do with Ladybug than the sort of basic stuff that we're going to start with. But this is a good starting point for us today. So the first thing we need to do is I'm going to set up a couple components. So I'm going to bring in the sun path, and that was this guy here, LB sun path. So this is actually not necessary for any of the outputs that we're doing in Skills. However, I think it is a really useful thing to understand what we're trying to get out of this process. So I'm going to take on here the location, and I'm going to link that into location. Next, we need to feed a bit more information in. So HOYS is hours of years, I think, hours of the year, something like that. Basically, it understands a count of hours that happen in the year from 0 to whatever 365 times 24 is, and understands them numerically. So there's a component here that we can use to generate those. So first we can do analysis period, and that will be this guy right here. And you can also, with any of these commands, if you type in LB analysis period, it'll bring it up. You have to type in LB first. LB is just Ladybug, the short abbreviation that you need to do in order to start searching for these. So it wants the start month, start day, start hour, end month, end day, end hour, and time step. So I'm just going to type in 12 to get a slider that goes from 0 to 100. I'm going to edit it so the max is 12 so I don't accidentally go over. And plug that into the first one. Oops. And copy and paste it. Now, the start day is going to want to go higher, so I'm going to set this to be a max value of 31. And for each one of these, when I'm changing these, you don't actually have to make these sort of set. It's just easier later on. Again, copy one more time. And this time, again, I'm going to right click and do edit. And then this is going to be for start hour, so I'm going to set this to a maximum of 24. And I'm just going to copy and paste these. So this wasn't entirely necessary. Setting up the sliders is necessary. Setting up the maximums just makes it a little bit easier for you later on. And these little, once you have things selected, these little toggles here allow you to make them a little bit more orderly. So I want my start month, in this case, to be number 1 for January, start day to be the 1st, start hour. So we're really only concerned with hours in which the sun is in the sky. So if we go too early, we're not going to get any information. So I'm going to start with 8 a.m. and end month is going to be 12, end day 31, end hour, let's do 17. So you got to think in military time, so 0 to 24, so 17 would be 5 o'clock. Okay, so that basically gives us an output of HOYS, and I can plug that in. If I click on this now, basically it generates this little thing here. This is essentially the sun path that shows the sun at each position every hour of the day between 8 a.m. and 5 p.m. on every day from the very first day of the year to the very last day of the year. And that's every position the sun will be in. So these little dots here are basically all those positions. So essentially, oops, do that again real quick. In all these scenarios, this little loop that you see here, this is the same time on each day, but just depends on which day of the year you're going or you're looking at. So we can do the same thing with this option here that just allows us to calculate one single day. So I'm just going to copy these and plug them in. So if we're more curious to see what does the sun look like on one single day of the year, we can do that, and it should give us a single point. And I'm going to make it a little bit later in the day. Let's see, 1 o'clock. So our point is right there. You can see it. We could plug in, I think if we plug in the, how about the wind speed? No, we'll do dry bulb temperature. So that's just the temperature. Plug that into data. It will color the sun. You can see here, based on the temperature that it would be at that time. It makes more sense when we start to see them all. You can see with them all colored, these are colors based on the dry bulb temperature of the at the day, at that time, the average temperature basically. So you can see that essentially as it goes up along this curve, we're getting towards the summer months where it's hotter, and as it goes lower, we're getting towards the winter months where it gets cooler. And you can see that by the temperature difference in the color there. But it also makes sense because in the summer, the sun is higher in the sky, so the shadows are shorter. Whereas in the winter, the sun is lower in the sky with longer shadows. And this is just a visual representation of this. So this little sun path thing, we actually don't need this for this assignment. I'm just doing this because it really is sort of fundamental to understanding the way the sun moves across the sky and the way this software actually works. So that's the sun path. We can turn this off, and I'm just going to right click and do disable because we don't need that to continue calculating. I'm just going to put it off to the side. Again, you can do that. I think it's good information to understand. It's not necessarily for the assignment, but it is really useful to get an idea of what is actually happening. So next, we're going to need a couple other components. So we're going to do LB accumulative sky matrix, which would be this guy here. The output here is not going to be anything that we're going to understand, and that's okay because we're actually trying to get this data here that's called sky matrix, but we need to feed it with some data first in order to be able to get that out. So the first, we need to do the same thing of just plugging in the location. And again, we're pulling data from this EPW file, which is just a data file that has a bunch of climatic data for us. And now we're going to plug in the direct normal radiation, or RAD, into direct radiation, and diffuse normal horizontal radiation into diffuse. If you only plugged in one of these, you would only be looking at sort of either direct radiation or diffuse radiation, but we're going to be looking at both. And I'm going to plug in my HOYS value into here. So now this essentially, it'll take a few seconds to calculate, but it has, again, visual. It doesn't have any sort of visual that goes with it. This is just data that the next component needs in order to function. The next component we're going to use is going to be the incidental radiation, or incident radiation. Again, it will be this one right here. And we just need to plug in the sky matrix. Now, this is the one. The first thing we're doing here is we're going to calculate the sort of radiation value, or the thermal energy in the form of radiation that is hitting any one point on our site. And we're going to be concerned with the site itself and the building on our site. So I'm going to select the building, the site outline that was given in the file. I'm actually going to load that in. So I'm just going to type in CRV to bring up a curve component. Right click to set that curve. So now if I have this unselected, you should see it's green. And the first thing I'm going to do is type in an area command. And this will tell us that the area is 31,400. But more specifically, it gives us a center, which is actually going to be useful for us later on. But the next thing is I'm going to do I need a surface. So I'm going to do a boundary surface, which is just a sort of standard surface that creates a surface off of a closed planar set of curves. Plug that in. Now, I know from having done this that it's going to give me an error, but I'll go through the process and show you what the error is. However, the next thing is I need to select all the context buildings. So in Rhino, I can do the SEL poly surface, and I'm going to separately not select the buildings of my design, just select the context. And I'm going to bring that into Grasshopper here. I'm just going to do a brep component, which is just a folder that holds geometry, and just going to set multiple. So now all of those are loaded in. So if I click on that brep, we should see they all turn green. So I can plug this into context. And basically you have two components here. We have context and geometry. Context will affect the shadows, but won't take any calculations themselves. So we're not concerned with the light hitting these buildings. Anything that is plugged into geometry will both affect shadows as well as get calculations on them. So I'm going to bring in my building separately as a separate brep, and right click, set multiple. And to keep myself sane, if I right click on these, I can rename these. So I can do my design, and we'll rename this one context. And that will be really helpful later on as we do this, because we are going to reuse these components multiple times. So if I plug in my design into geometry, I'm also going to plug in this boundary surface that I created. And again, I know, so we have to hold shift in order to plug two things in at once. So that will solve that for us. Now the thing is still orange and it's not ready to run yet. There's a few other things that it wants from us. The first is the grid size, and that's just wants a number. I'm going to put in 5. And all this is, pull these things over so we can see them, is grid size is basically the resolution of the calculation. And it's wanting sort of model units. So my model is currently in feet. So if I do a grid size of 5, it will essentially do calculations on a 5 foot by 5 foot square, and that will be the resolution of it. In general, I think that's a fine place to start. If we wanted to get more in depth about really what's happening on the model, we could increase the grid size to something smaller, but 5 feet will be fine for us. The next is it needs an offset. And this is just, we can just put in a small value here. Essentially, as it creates a surface, which we'll see in a second, it has to offset that surface in order so that it's not coplanar with the original surface that we're looking at, so we can see them separately. It's a minor thing, but just put in 0.5, which is just going to be a 6-inch offset. Again, it's really for a visual thing. The next, we need a set of switches. In this particular case, we're looking for a Boolean toggle. Just load that in. It should look like this. It starts off looking like false. We need 2 of these. These are essentially just switches that set an operation. So we're going to set the first one to true and just plug it into where it says parallel. And all this means is that it's asking, should it run on multiple cores of your processor? So you have in all computers, you have a CPU that has multiple processing cores. If you want this to run quickly, you want it to run in parallel. So it uses all of them in the best way it can. However, it will slow down the rest of your computer. So while it's doing calculations, your computer will feel sluggish. If you don't want that and are willing to wait the extra time, set that to false. But in general, setting it to true should be the way to go. The next is I'm going to plug in the toggle that is currently set to false into the run command. And I want it to be set to false right now. Basically, once this is true, this component will start running, will start calculating. So we don't want to set that to true until we know that we need it to be. So I know this is going to give me an error, but I'm going to turn it on anyways. And it might take a couple seconds to calculate. So the error here is going to be probably a fairly common one. And that is that if we look at the surface on the ground, it is only one color. It shouldn't be that color because we know the sun is hitting that surface. And the reason is all surfaces have a upside and a downside, referred to as normals. This surface, we're seeing the downside. For whatever reason, when it got created, it created the reverse normal. So if I type in the command flip and bring that into Grasshopper, I can essentially take that surface and flip it. And then I want to set this to be false. Bring that in instead along with my design. So now the flipped surface is in place. And when I set it to true, now we get, I'm going to hide this for a second so we can see what's actually happening here. Now we're essentially getting the calculations that we want. So what this is telling us is it's giving us a numerical value of kilowatt hours per meter squared, essentially a calculation of energy that's hitting it across the entire year. So we'll go back and we can make some adjustments to this, but essentially this is telling us from January to December, January 1st to December 31st, between the hours that we set, this is how much solar radiation is hitting each one of these squares. So you can see if we lowered the number on those grid size, these squares would be smaller and we have a higher resolution image. But this is plenty for our current design and where we are. Now, because we've done this in Grasshopper, of course, everything here is still movable. So if I move this roof, I can get an idea of what happens if I shift it. It'll take a second to calculate, but you can see here, all the color values have changed. So this surface, vertical surface here, is a great example. It is mostly orange, telling us that it's getting quite a bit of solar radiation. If we bring the roof back over and align it to the front building, we can see that roof is now in the blue values and the sort of yellow values, telling us it's getting a lot of effect from that shade that we've now put on the roof. So when you're designing your buildings to be taken into the software, it's good to, again, keep relatively simple forms. As the simpler they are, the easier it's going to be for the software to do all of its calculations. But having enough detail, like this roof element here, can help give us a lot more information about the impact we're having. Now, since we are designing a pool, this will also give us some information about where the pool is going to get the most sun. So, a concern obviously for pool is getting direct sun. It helps heat the water of the pool, making it more enjoyable to use. People like this layout in the sun. So at least as this is currently designed, if you wanted an outdoor pool, this region here in sort of the northern portion of the site would make a lot of sense for an outdoor pool right now. And you can see if you put it right next to the building, you will have pretty direct shading from this. So this will be the first exercise. So once you are happy with this, what we can do is go back to the Grasshopper, and I'm going to make a mesh component just by typing in mesh, and it's one of the params. So it gets this little black hexagon, and I'm going to plug the mesh in there. And now I can just bake this mesh, set it as a group, and essentially it becomes physical geometry. So you can now move this around in Rhino independent. However, it is now detached from Grasshopper, so if we were to move that roof again, it will have no effect on the calculations that you see here. But essentially, set up an isometric view. So again, as we've done many times before, go to an isometric. I'm going to do northeast. Actually, I'm going to do southeast. Sorry about that. Isometric, southeast. Pick whichever view you think best sells it. I'm going to use the named views, which you can type in. You can get to by typing in named view. I'm going to bring up this panel here so we can save this view and save it as parallel spine. So now each one of your views, when you're ready to export, and you may want to go to a different export type. So, this is just, I think, in the standard rendered or shaded. We may decide to go to a rendered view or the Arctic or whatever it may be. Doesn't matter too terribly much what we pick, but just export something that looks pleasing to you. I would turn on print display, mostly so that our lines will be black and white and not the weird colors that you might be drafting with. So this is the first exercise. So just get to this point with your design, again, placed right here. And this would be the first thing. Just do a view capture to file. Save it as whatever. Again, as usual, make sure your resolution is probably above 3000. So setting a scale for me at least to 2 will allow me to make sure that I get a high enough resolution. And that'll be it for the first exercise. The second one I'm going to go into right away. So let me bring back the Grasshopper. All right. I'm just going to get organized again real quick. Get this to snap the way I want. And I actually am going to delete this. So I've created the mesh, and at this point I would have saved my view, so I don't need that anymore. And I'm going to set the toggle here to false, and I will actually just take all of this stuff and, well, I'm not going to take all of this. I'll take most of this stuff and disable it. I don't need that stuff right now. And again, just trying to save on calculation time. Anything that doesn't need to calculate, I'm going to not want it to. And I'm going to bring over, this was my curve that brought in the site, the area for the center of it, and the boundary, and the flipping, because I will be using those again. Next thing I'm going to do is the windrows. So it's this guy here, the arrows pointing in towards each other, that's blue. And with this, so the windrows is looking for a couple things. We need to feed it some data. And specifically in this case, we can actually just follow the prompt. So it's asking for wind speed, which is going to be into the data, and then wind direction, which is going to be into wind direction. And it should feed us this. Now we want it to be centered on our site. So actually that's where we're going to use the center of the area command. And we're just going to bring that over to center point, and it should just shift. Again, I'm going to do a mesh command, which again just brought up a sort of box, an empty param that we can put a mesh into so that I can bake this. And I'm just going to bake. This one is quite easy. And I'm going to hide my little model that I made just so we can see this guy by itself. So this is the windrows. Now we could hide the rest of the buildings, as these aren't really necessary for this either, but this gives us an idea. This is the sort of direction of the wind as it is impacting our site. We could take this whole thing and scale it. It doesn't really need to be as large as it is. Maybe we make it a little smaller. But the important thing is understanding what this data means. And essentially we're getting a lot of wind from this direction, not much from this direction. Now this windrows isn't taking into account the actual buildings. This is just the wind that was measured at the airport, which was CVG. So we have to kind of take that with a grain of salt. We can use this software to calculate the wind patterns that would go across our site, given this sort of input data, as well as the fact that we have these buildings here. But that is quite a bit more complicated, so we're not going to be dealing with that today. It actually involves calculating fluid dynamics of wind moving across buildings, which is a complicated thing to do. So basically, once you've created this, do the same thing as we did before. You capture the file and export this. All right, so the next thing is we're going to delete this again once we've saved our view. And we're going to go back to our Grasshopper. And the final thing that we're going to be concerned with is going to be setting up, I'm going to disable these as I've done with everything else. We don't need them to calculate anymore. But we want to now set up some shadow studies. And we're going to look at a particular day on a particular day of the year. So I'm going to go and bring out this component that is LB direct sun hours and bring that in. Make this large again. So this component is going to use several things. So we actually are going to use the sun path that we had calculated earlier. So I'm going to enable this guy again and bring him down. So we're going to plug in vectors into vectors. Again, oftentimes a lot of these things are maybe not self-explanatory, but at least they're trying to give you as many clues as they can. So as I mentioned, we are going to reuse the context. Where did I put that? So these little components that I had actually turned off, these were the context in my design. I'm going to enable them again as we need to use them once more. Because with shadow studies, of course, we are concerned with the shadows cast on site. So we're going to plug in my design into the geometry. Actually, no, we're not going to do that. We're going to plug that into context because we're only really going to be concerned with the light hitting the site itself. We're not actually concerned with the light hitting our design right now. So I'll plug context into context. And instead of just using the site this time, I'm actually just going to create a much larger area. So I'm just going to do a circle CNR, which will give us, and basically use the center area of our site as the center. And normal will be up already, and we'll just set the radius to 200. And essentially, this is just going to create a giant circle. And then do the same, create a boundary surface. And I just copy and pasted the same one, but that was a boundary surface. Again, just the same component that creates a surface from any closed planar curves. And that's going to be the geometry that we're going to be interested in getting. So next, we need to have a grid size again. And for that, we're going to need a value. I'm going to do something a little bit smaller this time because we're not doing as complex calculations, because we're only going to be concerned with one day of the year. And then I will plug that into grid size. And then, of course, we need the same booleans. So these are the Boolean toggles that we had before, which are just these switches that go between true and false. And I'll bring these up. So I want this to run in parallel, and I want this to be set to false. Now, if I run it right now, it's using the original HOYS data that we had input, which was basically all year. Now, for that original incidence of radiation, we could use the all year data if we're interested. The other thing we could do is we could look up, say, what the swimming season is. Offhand, I don't actually remember what it is, but I'm just going to put in, let's say, April till, actually, let's do September. So now our period is from April to September. And we could have done that same thing for our radiation study. In fact, I think it would be interesting to do the same radiation study looking at the opposite seasons. So from April to September, and then from September to April, and just see what the difference is between the two. Because there certainly will be a difference based on sun angles. As well as this also takes into account the relative power of the sun in the summer versus the relative power of the sun in the winter. So we can get an idea of how much more light we'd be getting potentially in our pool, say the indoor pool that is supposed to get direct sunlight, that's supposed to heat up in the winter or something like that. Anyways, so we're actually only going to be concerned with a single day of the year. So I am actually going to use this original component that I had made, which was one of these guys. And this is looking a little chaotic. I'm going to try to organize myself a little bit. But it was this guy here, which is calculate HOY. And I'm going to set this to, let's do 6. You can do any day of the year you like. And you can do any hour. I think I'm going to do a nice 9 a.m. on 6/20. And I will plug that in. Actually, I'm not going to do 9 a.m. I'm going to do 7 a.m. Because right now, essentially what this will do is I'm going to hit true, and it should be a relatively quick calculation compared to some of the others. And we can see here, we're just getting these really kind of rough shadows. And that's because we're only getting one time of the day based on the data that we have right now. And it seems like a pretty intense shadow that we're getting. I guess this is fairly early in the morning. What time did I do? 7 a.m. Oh, that's why. Now, the interesting thing is the HOY data is actually just a number value. So in the 6 months, the 20th day, the 9th hour is the 4,089th. I'm sorry, I actually had this on the wrong screen and I forgot that I was only sharing the one. So I'll just show that again. But the HOY value that we have here that was created, again, with this guy up here, just calculates a single day. If we hover over this, it'll show us the value that it's exporting on the 6 months, 20th day, 9th hour. And that would be the 4,089th hour of the year. And that's all it's really concerned about. So I actually want to get more than 1 hour And I don't want to necessarily use this component here. This component will give me every hour, and I could set it up to end on the same day it began, but it would still give me one value per hour. And right now, I actually want to do every other hour because I only want a certain number that I want to be able to see. So I'm going to just, knowing that I just need a series of values that are essentially numbers that are the hours of the year, I'm just going to do the series command. And what this will do is ask me for my starting value, which I'm going to use that hour that we calculated on that particular day. And I want to set a number of steps and then the count. So the number of steps I will set to 2. So that means it's going to add 2 repeatedly. So the first hour would be 9 a.m., then 11, and then 1, et cetera, et cetera. And then I'm going to calculate how many of these do I want. So if I do 5, that'll give me a total value of 5 values. So let's plug that in instead. And we should get more interesting shadows coming out now. So I still have my, put this aside for a second. I still have my building calculating, even though it was hidden. And we can see here on that particular day, again, since we picked a summer day, the shadows are coming from mostly above. So anything that is in the sort of pure yellow that we see here, those would be days or areas of the site that are getting no shadows whatsoever. And basically the darker the value towards blue, the more intense that value, the more that is in shadow. So if we now switch this to be, say, let's do today, 11, start again, 11 and 2. So now we can see what the sun would look like and the shadows would look like on site today, every 2 hours, given those inputs. So that is actually the last thing that we're going to be doing for this. So I'm just going to create another mesh component and plug it in, and I will bake this mesh. Yes, please. And now essentially go back to the same view and view capture to file. And that'll be it. So hopefully this was fairly straightforward. It is a complicated software and there's a lot more that we can do with it. So of course, I think the biggest value right now is that sort of initial thing that we did where we actually drove a sort of analysis of our own designs. Oh, turn that on again. I need to turn more components on apparently, but that's all right. That sort of analysis that we did in the very beginning where we can actually see how much light we're getting depending on our design, I think that's really important, especially as we're looking at this pool and we're trying to decipher and make decisions about how we place buildings on the site. Using that as a way to sort of inform those decisions, I think can be a really powerful tool for a design. The shadows, of course, I think are going to be useful as well, and understanding the windrows, which will certainly affect people's comfort on site, I think are, of course, also valuable things to consider. But as a design tool, I think that first one we did is really going to be where you're going to get most of your value. Now, of course, this being Grasshopper, everything here that we just did was just the manipulation of data. So we could take this data and we could inform another aspect of the project. So for example, the previous assignment we did a screen or a facade that had apertures that open and close. We could drive those openings and closings of an aperture purely based on solar data. So we could use how much direct solar energy any part of the facade of a building is getting to inform how big the opening should be, for example. I'll probably do a supplemental where I take one of the definitions that we did in the last Grasshopper assignment and essentially plug in this information to show how you could directly tie solar information into a design of an actual building facade. But for this assignment, all we're really concerned about is getting the sort of 3 images that should look something like that. So shadows, the windrows, and then the thermal energy just looking at the site and your building on the site. Okay, if you have any questions, let me know.